Hello friends, let us now learn some important points about the basic interactions of X-rays and matter. So, basic interactions of X-rays and matter. Atoms are bound into molecules. So, when electrons pass from cathode to anode, X-rays are produced. Now, how these X-rays interact with the patient body is what we are going to deal in this chapter. So, atoms are bounded into molecules by electrons in the outer shells. X-ray photons may interact either with the orbital electrons or with the nucleus of the atom. In diagnostic energy range, the interactions are always with the orbital electrons. If these electrons happen to be the ones bonding atoms into molecules, the bonds may be disrupted and the molecular structure is altered. The molecular bonding energies, however, are too small to influence the type and number of interactions. So, the important factor is the atomic makeup of the tissue, not the molecular structure. There are five basic ways that an X-ray photon can interact with matter. They are coherent scattering, photoelectric effect, Rampton scattering, pair production, and pair disintegration. As we discuss each of these interactions, we will see at times X-ray photons may be absorbed or at other times X-ray photons are scattered. When X-ray photons are absorbed, they are completely removed from the X-ray beam and they cease to exist. When X-ray photons are scattered, they are deflected in the random course and no longer carry any information. Because their direction of deflection is random, they cannot portray an image, and only thing they produce on the film is blackness. In the language of information transfer theorists, this scattered radiation adds noise to the tissue. So this noise created by scattered radiation is called as film fog. So let us first learn about the coherent scattering. The name coherent scattering is given to those interactions in which the radiation undergoes a change without change in wavelength. So this coherent scattering is also called as unmodified scattering. There are two types of coherent scattering, Thomson scattering and Rayleigh scattering. So in Thomson scattering, a single electron is involved. So in coherent scattering, there is change in direction of X-ray photon without change in wavelength. So for this reason, the term modified scattering is used. There are two types of coherent scattering, Thomson scattering and Rayleigh scattering. In Thomson scattering, single electron is involved in interaction, whereas in Rayleigh scattering, whole of the atom is involved in interaction. So in Rayleigh scattering results from the cooperative interactions with all the electrons of an atom. Both types of coherent scattering may be described in terms of wave-particle interaction and therefore sometimes called as classical scattering. So when low energy photons might hit the electrons, then the electron or atom will vibrate. Low energy radiation encounters the electron. The electrons of the atom are set to vibrate at a frequency of radiation. The vibrating particle, because it is a charged particle, this emits radiation. So this process may be envisioned by the absorption of radiation, vibration of the atom, and absorption of X-ray, vibration of atom, and the emission of radiation as the atom returns to the normal state or undisturbed state. This is the only type of interaction between the X-rays and the matter which does not cause any ionization, and to produce ion pair, the photon must transfer energy to the atom. But in this coherent scattering, no energy transfer and no ionization occurs with coherent scattering. Its only effect is to change the direction of the incident radiation. The percentage that undergoes coherent scattering is very less compared to other basic interactions. So if you see X-ray strikes the atom will is set into vibration, then the X-ray will deflect to its opposite direction And when the X-ray deflects to the opposite, deflects in other direction, the wavelength will be same, it will be the same wavelength. So incident photon and the deflected photon has the same wavelength. The percentage of radiation, this is a scattered radiation. The percentage of radiation that can undergo coherent scattering is very small when compared to other basic interactions. In general, it is less than 5%. Some coherent scattering occurs in diagnostic energy range, but it never plays a major role. Even though it produces the scattered radiation which contributes to film fog, the total quantity is too small to be important in diagnostic radiology. The second important thing is photoelectric effect. Before the beginning the discussion of photoelectric effect, we should know the this is the nucleus. Around the nucleus there are electrons revolving in orbitals. So when an electron, so this is the K shell, innermost shell is called as K shell and the outermost shell is called as L shell. So the atom consists of central nucleus and orbital electrons. Nucleus is very important to the present discussion as a means of keeping the electrons in the atom. The positively charged nucleus holds the negatively charged electrons in its respective orbits. The innermost shell is called as K shell and the more peripheral shells are named as L, M, N and so on. These shells have a limited electron capacity. K shell can hold 2 electrons. If electrons are present in an atom, they move out to the L shell which has a capacity. If more electrons, see K shell will accommodate only 2 electrons. If more electrons are present in K shell, they accommodate in the L shell which has a capacity of 6 electrons. Each shell has its specific binding energy. The closer the shell to the nucleus, the tighter the electrons in that shell are bound to the nucleus. So the electrons in the K shell are bound tighter, whereas the electrons in the outermost shell are loosely bound. So these electrons which are in the outermost shell and are loosely bound are called as free electrons. The energy value of the electronic shell is determined by the atomic number of the atoms. K shells are tightly bound in elements with high atomic number than they are in elements with low atomic number. In fact, the differences are sizable. For example, K shell of lead has a binding energy of 88 kilo electron volts, while K shell binding energy for calcium is only 4 kilo electron volts. The electrons in the K shell are at lower energy than electrons in the L shell. So let us learn about the photoelectric effect in the next class. Thank you.